Okay, let's look at number 15. 2 cards are drawn from a deck with replacement. What is the probability that the first card is an ace and the second card is black? So this is very straightforward. The first card is an ace and the second card is black. So because this is an and, it's going to be a multiplication. So the probability that the first card is an ace, there are 4 aces out of 52 cards. And we're going to multiply that times the probability that the next card is black, which there are 26 black cards out of 52. So when we multiply that, we get 104 out of 2704, which is 1 over 26. And again, we'll go over in more detail how to simplify a fraction like 104 over 2704. Okay, B, neither card has a value of 2, 3, 4, or 5. So we want the first card is not a 2, 3, 4, or 5. And the second card is not a 2, 3, 4, or 5. So once again, this is going to be a multiplication because we have the word and. We have to ask ourselves how many 2, 3, 4s, and 5s there are in a deck of cards. There are 2 of each. So, there are 4 of each. So that means we have 16 cards. So the probability that it's not would be 36 out of 52, which is just 52 minus these 16 cards. And we're going to multiply that times the same probability because once again, it's not a 2, 3, 4, or 5. So 36 over 52. That is equal to 81 over 169. All right, let's look at C. C is both cards are spades. Once again, we're looking at a multiplication, a spade and a spade. So 13 of the cards are spades, 13 out of 52, times 13 out of 52. And that actually simplifies to 1 out of 16. Okay? And remember, it's still over 52 because it says specifically that 2 cards are drawn from a deck with replacement. So we know that each time we have a full set of 52 cards to choose from. All right, this next one is the first time we've done the complement rule. We did talk about it in class, but this is the first time that we've used it. It says at least one card is an ace. Okay, so the first card could be an ace or the second card could be an ace. That's actually fairly tricky to figure out because there are many different combinations that could come up with a hand when you draw 2 cards. At least one is an ace. Because again, remember you have 4 aces. So you could have a ace of hearts, you could have 2 aces, there's many different combinations. So whenever you see the word at least, okay, the complement of at least is none. All right, so seeing the words at least is sort of a hint that you're actually going to find the probability of none and then subtract. Remember, the complement is when you have 2 things that make up a whole. So if we have at least one of the cards is an ace, the opposite of that has to be that none of the cards are an ace. And the probability of those 2 events is equal to 1. So what we're going to do is find the probability that the first card is not an ace and the second card is not an ace. Okay? All right, and then we're going to use the complement rule. So the probability that the first card is not an ace, there are 4 aces in the deck, So the probability it's not an ace is 48 out of 52. It's an and, so we're multiplying. And then obviously the probability doesn't change. It's still 48 out of 52 that it is not an ace. And that is equal to 144 out of 169. But since the probability it's not an ace is the complement of the probability that at least one is an ace, we would do 1 minus 144 over 169. And that gives us 25 out of 169. And it's a much easier way to determine that probability. Okay? And E, the first card is an ace, or the second card is black. Ace, or black. So I've changed it a little bit because we have an or. This is going to be an addition probability. So the probability that the first card is an ace is 4 out of 52. We're going to add that to this probability, which is 26 out of 52. But once again, we have to ask ourselves if these events are mutually exclusive. They are not, because 2 of the aces are black. So we need to subtract that out. And that gives us 28 out of 52, or 7 out of 13. Okay?